So everybody, most welcome to this webinar on Let's Go Beyond the Climate Crisis and Start Talking About Solutions. The reason we're hosting this webinar is that we think that in the news there's not way too much, but there's a lot of bad news out there around climate change that's already happening, emissions that are continuing to go up. We're very aware of those, but sometimes we feel that the positive stories are a little bit underrepresented. And as we're investing in solutions, and there's so many incredible solutions being developed and scaling rapidly, we wanted to share some of these stories with you. So that's what you can expect. We'll go through all 6 climate sectors, and per sector we'll discuss 3 examples, so 18 companies in total. Better prepare, there's a whole lot of information coming your way. What we won't do is talk about our funds. For that, you can really go to our website and find much more information, or send us an email afterwards. Feel free to introduce yourself in the chat if you'd like, to let the other people know who is here. And finally, questions are very, very welcome. Please ask them in the Q&A section, and then we have a good overview and we'll ask them when it's convenient. What we'll try to do is create a moment of Q&A at the end of every sector to make sure that if you have questions about specific companies, we can address them while we're still kind of have them top of mind. So please shoot them over as soon as you wonder, wait, how about this? Next to that, you can send us public or private messages if there's anything else that you think is important. So in terms of the agenda, we're going to talk briefly around the bigger climate problem, but then we're mostly going to dive into the 6 sectors that we need to develop all kinds of solutions in to get to net zero. And for every sector, we'll give you a brief breakdown of where are the emissions actually coming from, and then 3 of our favorite companies that we've helped fund in that sector. And as said, per sector, we'll do brief Q&A moments, as well as one on the end if there's more general questions. So who will you see in this webinar? Not only me, but also my amazing team. So we have Carolina Jacopar. She's been with us right from the start. And then we have Itze and Eva, who both joined us more or less a year ago. All 3 of them sit in the investment team. So they're full-time working on doing deals, both funds and co-investments, and the necessary research to really understand what it is we're investing into. I'm Lisa, I'm one of the co-founders of Carbon Equity and Chief Climate Impacts. So the problem, right now we're at 59 billion tons of CO2 and equivalents emissions per year. We need to get that to 0. Now, where are all of these emissions coming from? Basically, it's 5 sectors. We have energy production, we have industry, food and land use, transportation, and buildings. And then there's one sector that we really need to build from scratch, and that will help us to remove whatever residual emissions or overshoot emissions we have, and that's carbon management. What you see on the right-hand side here is the highest level, so these 5 sectors, and then the first breakdown after that. We'll dive into those a bit more per sector, but I also already want to point out that all of this information is also on our website in the Climate Tech Hub. Now, how do we actually solve all of these emissions? Basically, we need a pretty well-defined set of technologies. Whether you're talking the IPCC reports, all the trajectories in there, or the IEA reports, or any other institute that is predicting how much global warming we're going for, what's necessary to stay below 2 degrees, they always use more or less the same set of technologies to describe what it is we need to do to get to net zero. And that set of technologies you can put into 4 buckets. There's one bucket of technologies that are really mature and already globally being deployed. Here, solar panels are a good example, onshore winds. You can think about all sorts of plant-based milk equivalents. Your oat milk by now is really a mature technology. And these things are available at scale and are typically cheaper or at the same price as the alternative. Then we have everything that's in commercialization, means they're already available on the market. There's probably a few different options out there, but maybe they're not as easily accessible. Maybe they're not as cheap, and maybe there's a few specs that are not fully on par with the current incumbent technology. And you see that's 45, so it's really a big bucket already. And you'll see a lot of familiar names in there. Heat pumps, some of you might already have one in your home. Electric vehicles, some of you might already own one. Those are rapidly heading towards maturity, but not quite there yet. Then the third bucket is the early innovation. This is the kind of stuff that a lot of companies are working on developing, and they've probably done some pilot plants. So at a small scale, they've proven that we can make this stuff. But we need to figure out how to make it most efficiently at a larger scale. And so there's still a lot of design challenges underway, some technological risk, and a whole lot of capital is necessary to actually start designing these larger plants. And then finally, 5% of emissions. This is the in-concept stuff. This is really the next-gen ideas, the big breakthroughs that, you know, maybe by 2050, maybe a little bit earlier, these will start to come online. It's really not the bulk of what we need for net zero, but those are the kind of things that could change the game and also after 2050 continue to improve the system. So with carbon equity, we invest mostly in the three on the left-hand side. So it's the in-concept, the early innovation, in commercialization. It's because most innovation still needs to happen there. And all of the examples I will share in this webinar are really from those three buckets. One word on kind of, okay, how does all of this add up? So what you see, first of all, is the share of emissions coming from each of these sectors. We'll dive into a bit more in that after this. But I also just want to highlight, but by now, Carbon Equity, we've helped fund 160 companies. So you see there was plenty to choose from for every sector. We'll share 3 examples now, but in the Climate Tech Hub, you can continue reading if you want. So over to you, Eva.
Yes, thanks. So let's start with energy. So energy is a sector where the most emissions come from globally, actually. So we use energy everywhere to light our homes, to power our cars, and to make all the things we use, for example, on land. But it also actually costs energy to produce energy. So actually 33% of all global emissions are created when we produce electricity and fuels. So to transition to a zero emissions in the world, we need to electrify everything. And that means we are going to need even more electricity. And we also have a rising population. That also means that the demand for electricity is increasing even more. So in 2050, we expect that we need 3 times more energy than we do need today. So our first challenge here is actually to produce electricity in a cleaner way and to generate more electricity. So luckily we have a lot of great innovations like renewable energy, such as solar and wind energy, that already became even cheaper than fossil fuels. And this also brings us to the first 2 exciting companies already. Yes. So like I said, we need to electrify everything, and we are already doing a good job here. So we use electric cars and we generate solar, wind, hydro, nuclear energy. But while we electrify everything, we are also creating 2 new problems for ourselves. So the first one we actually create by asking for more cleaner electricity, and that is grid congestion. And that actually is a traffic jam on the grid. So you see this happening almost everywhere, especially in the Netherlands now. You see that we are generating a lot more solar and wind energy that all needs to be added to the grid when the sun is shining or when the wind is blowing. But the grid cannot actually handle such amounts of energy when the demand is actually not really increasing. So this is a really big problem for buildings and for companies that need more electricity, especially when they are start electrifying, for example, if they start electrifying their fleets. So these energy consumers cannot get access to energy now, and that's a huge problem. So the solution for this would be to increase our grid capacity. That means we need to make our grid networks more extensive, but this costs a lot of money and time. So the first company you see on the left-hand side is TS Conductor, and they are tackling this problem by producing grid transmission lines, and that are actually the cables you see in the air. And their cables have 3 times more capacity than the lines we use today. So in other words, it can transport 3 times more energy at the same time than the cables we use today, while also losing less energy while transporting the energy. So the other problem we're facing when we try to electrify everything is the problem of grid intermittency. And that actually means that the sun is not always shining, the wind is not always blowing, so we don't have energy all the time. meaning we need more sources of baseload power, and this is actually power that is constantly there, but it's still clean. An example of that is geothermal energy. Or we should store energy that we produce at times that the supply is more than the demand. And the company on the right-hand side, so Form Energy, is doing this. They can store energy for multiple days, and their technology is an iron air battery that simply uses the process of rusting and derusting to store and release energy. And Form Energy is doing a great job here, that they're one of the first movers that can store energy for such a long time. So then within energy, we have the electricity and heat problem, but we have a second challenge, and thereby also the third problem, company. Thank you. So the second challenge is we cannot electrify everything yet. So we have been using fossil fuels to power the industry, for industrial heat, and for big transport like airplanes. We have been doing that for a long time. But burning these fuels release emissions, obviously, but one step earlier in the process to actually make those fuels, we're also releasing emissions. So electrification of some of these sectors is super challenging, and that's why we still need fuels, but we need to produce them in a cleaner way. And I think Koloma is a great example of a company that is actually doing that. So they developed a technology that can extract white, or others call it gold hydrogen, from underneath the ground. So hydrogen is something we use a lot today already, so especially in the chemicals industry and in iron and steel production, but we mainly use dirty hydrogen, so produced from fossil fuels. There are some alternatives like green hydrogen, which you can generate by splitting water into hydrogen with renewable energy. This process is called electrolysis, which we believe is a great technology, but it can still be expensive, and you do require a lot of renewable energy. So the scientists behind Koloma and other scientists, they discovered another form of clean hydrogen, and that is the hydrogen that is stored naturally under the ground. So under the ground, a natural reaction is happening between rocks and water, happening all the time. And studies estimate that 1/3 of the hydrogen we are actually demanding today can be already found underground. So there are great deposits of hydrogen located in Albania, in Australia, Brazil, France, and in the US. So this company actually operated for a long time in stealth mode, meaning they acted in secret. Their founders have studied geologic hydrogen formation for a long time, and I think that's really their competitive advantage. There are still a lot of challenges to overcome here, but we think this technology is really promising.
Thank you, Eva. I just want to do a brief pause to see if there's any questions, and otherwise move on to the next sector. All right, let's go to industry. Kara, take it away.
Hi, everyone. Nice to see you all today. I'll talk a bit more about industry. So industry is the next kind of biggest emitting sector, responsible for 25% of global greenhouse gas emissions. So let's dive a bit deeper into the culprits behind this. So industry as a term is, of course, very broad. What you should be thinking about here is basically any manufacturing process we use to make any material we use that goes within the industrial sector. So you can think about the concrete, cement that goes into our buildings, the steel that is also used in construction or to make cars or machinery, the plastic in our bottles, in our bags, the broad range of chemicals that we use for different processes, as well as our waste industry. All the waste we produce in cities needs to be managed, and is usually sent to landfills where it emits methane or is actually just burned, of course, leading to carbon emissions. And besides these top 4 emitting industries within the industrial sector, there's also another range of industries such as the textile, fashion, pulp and paper industry, for example, that also contributes to emissions. But I'll first dive a bit into the number 1 and 2, which are concrete and steel. Luckily, there are solutions trying to tackle these very large challenges. So in industry, actually, there is one common problem. The problem is that we need to achieve very high temperatures to be able to, for example, bind or melt materials like metals or rocks. And to achieve these high temperatures, so far we've been burning fossil fuels. This is a common challenge within both cement and steel production. So the companies you can see here on the slides, the first is Sublime Systems. Essentially, when you make cement, which is an ingredient that is mixed into concrete, you need to heat up limestone to a temperature of almost 1,500 degrees centigrade. And when you burn this limestone, actually in that chemical reaction, even more CO2 is released. So that is the problem we need to solve. And Sublime Systems has created first an electrochemical process. That means they can use it with renewable energy instead of fossil fuels, and it can happen at room temperature. So we don't need these super high temperatures anymore. And then they're using alternative materials to avoid this limestone reaction I mentioned. The other problem, or kind of top two problem within industry, is steel production. So here we also need to burn coal to reach temperatures of 800 to 900 degrees. Indeed, currently we primarily use coal, but we could use alternatives. For example, green hydrogen, which Eva already mentioned, which as an input, you only need water and renewable electricity. Green hydrogen can be an alternative to coal to reduce iron, meaning to take out oxygen. And then you can further convert this iron into steel via an electric arc furnace instead of the traditional blast furnace used today. So this H2 Green Steel company, you might have heard about it in the news, based in Sweden, raised already about 4 billion euros in debt funding, 2 billion in equity funding, really pioneering hydrogen direct reduced iron methodology today. And one company to dive in a bit deeper, as I mentioned at the beginning, the common challenge in industry is really that we need to reach these super high temperatures. So you can try to find kind of tailored solutions for every single industry like cement and steel, or you could try to just solve the high heat problem itself and then sell your solution to a range of industries. That is what Rondo Energy is trying to do. So essentially their technology is, in very simple terms, a box or a container filled with tons of bricks. These bricks are wired together with electric wiring, kind of similar to your toaster at home. And what you can do is charge up or heat up these bricks with renewable electricity. Once they're very hot, and they can actually reach temperatures of 1,500 degrees centigrade, which basically covers like 95% of industrial process needs. When they're very hot, you just pass air through them on top, which then heats up the air, and you deliver this hot air to your industrial customers. It can either be in the form of air or steam. Then you just need a water pipe to be able to heat that water pipe with the hot air. And then you solve the industrial heat problem. So Rondo currently has a small unit of this container in operation, and they're scaling up. So hopefully they will be able to indeed solve this problem. One other thing I'll mention just on Rondo is they're not only solving the industrial heat problem, but also the intermittency problem of renewable energy that Eva mentioned. So because it works like a battery, you can essentially charge it up or heat it up when renewable energy prices are low, and then use it 24/7 in your industrial operations, because it can store energy for days and only sees about a 1% energy loss per day. So yeah, quite a cool company we're excited about. And I'll happily take any questions on these companies if there's any.
Don't see any questions coming in, so I think we'll just go to the next one. And if you change your mind, still feel free to add them later. For now, we'll move on to food and land use, and I'll hand over to Itse.
Yeah, thanks, Lisa. So let's move on to food and land use. So our global food system is responsible for roughly 23% of global greenhouse gas emissions. And these emissions then come from the forest we clear to grow crops, to the methane burps from cows, but also the food we waste. And I think despite its impact, agriculture is really one of the slowest industries to change. It's due to vested interests, it's perverse subsidies. I think regulatory constraints for innovation also play a role, but also climate change itself. So the majority of the emissions in this sector come from meat and dairy production. And other contributors are, for example, fertilizer use, pesticides use for crops, fisheries, but also soil emissions and forest fires. And it's important to know that it's not only carbon dioxide that's driving climate change from this industry. So it's also methane, which is mostly released by cows and rice fields, and which is actually 28 times more potent than carbon dioxide on a 100-year timescale. And it's also nitrous oxide that's caused by excessive fertilizer use, which is actually 300 times worse on a 100-year timescale. Beyond these greenhouse gas emissions, I think this sector is also really closely linked with other environmental issues, such as biodiversity loss due to land use change, but also pollution from fertilizer runoff. So that makes this sector really interesting. By changing our farming and eating habits, we can at the same time reduce climate change, we can reduce biodiversity loss, and we can reduce environmental pollution. And although I think many don't associate this sector with climate tech, I think there are some very interesting and important innovations happening that would help eliminate emissions from this sector while still meeting the growing global food demand. So the first innovation I wanted to talk about is Planetary. So yeah, next to the animal welfare concerns, animal proteins are also responsible for 12% of global greenhouse gas emissions. And with population growth, with increasing wealth, meat consumption is only expected to rise. But fortunately, there is a new generation of technology that's bringing the plant-based proteins of today closer to matching meat in taste, matching it in price, but also matching it in nutrition. So precision fermentation is being used to create the exact same molecules as found in meat, as found in cheese. And this technology has already shown great promise in the lab, but the challenge has really been in scaling up production due to the high cost of biomanufacturing. So Planetary is tackling this barrier by building and operating so-called biofoundries, which are facilities that are specifically designed for efficient and economical production of biomanufactured ingredients like proteins. So these biofoundries really companies such as plant-based meat manufacturers to produce their products at scale without needing to invest in their own expensive, very capital-intensive factories, which makes precision fermentation more accessible and viable as a replacement for animal-based products. The next innovation I wanted to talk about is yardstick. So to turn agricultural land into a more thriving carbon sink instead of a net emitter, which it is now, farmers need to be able to manage it by shifting to regenerative agricultural practices like reducing tillage, planting cover crops, and increasing crop rotations and biodiversity. The problem is that you cannot manage something until you can measure it. And this is really where yardstick comes in. So they use a new approach, spectral analysis, to measure the specific wavelengths reflected of organic carbon in the soil. And this method allows them to calculate the amount of carbon in the ground without ever needing to disturb the soil or send samples to a lab, potentially 100 kilometers or further away. So they can take samples way faster and dramatically lower the cost. And this data can then help farmers to gain insights into how to improve the carbon content into their soils and turn agricultural soils into meaningful carbon sinks. The last innovation I wanted to talk about is Nitricity. So just over half of the global population could be sustained without nitrogen fertilizer derived from the famous Haber-Bosch process. Unfortunately, the production of fertilizer is very emissions intensive because we need natural gas to produce it. And over-application of the fertilizer results in the pollution of our freshwater resources and in nitrous oxide emissions. So Nitricity is developing solutions to both of these challenges by using renewable energy to produce plant-based fertilizers on a local scale. So they use a solar-powered technology that captures nitrogen from the air by creating a plasma and combine it with other nutrients that can be derived from agricultural waste to produce a variety of fertilizer products. And the technology is also designed to integrate into the irrigation system of the farmer, which means that they can also address the over-application of nitrogen fertilizer. Another key advantage to their approach is that it enables fertilizers to be directly produced on or near farms, really bypassing the carbon-intensive logistics of traditional fertilizer distribution. So it's a centralized production model, and it does not only reduce emissions, but also stabilizes prices for farmers, making it a very cost-effective solution. So yeah, this was a rapid-paced overview of the agricultural sector, but I'm happy to take any questions.
See, apologies. We do have one question from Erica from the Netherlands. Which of the three examples in these innovations is already up and running and making a financial profit?
That's a great question. So Planetary is now building out their first factory. So I think they will be up and running in the coming month, actually. Yardstick is already having pilot projects with farmers to introduce this technology. And Nitricity is already having projects at farmers in the US, where they're already producing on-site fertilizer production and selling this to the farmers.
So I think the answer is none of these companies are profitable, but that's typically also because the proceeds that these companies have, they reinvest in further growth. And they use actually the venture capital that we help provide to also be able to invest more than they're currently making in revenues.
Exactly.
There's another question. It's which is whether I'm going to rephrase, Albert. I hope you don't mind, but whether Yardstick can also be used to measure CO2 emissions from the soil in ecosystems, for example, in peatlands.
Yeah, it could, in theory, it could. You need to do it over time, right? So then you need to measure it in peatland ecosystems. And then, for example, if this peatland or the forest on the peatland has been cut down, then you can measure it again in the soil. So the technology can be used in every type of soil. So also for ecosystems, but it's mainly focused now on the agricultural sector. But yeah, it has wider applications.
Great. And then before we move on to the next sector, oh, there's another question from Erica about the previous category. So maybe I'll give that to you, Carolina, to talk about the stage of the companies in industry. And at the same time, you could answer another question we got, which is around what have we seen happening in industrial cooling when it comes to innovation?
Yeah, happy to. So I'll first start with the question on kind of the commercial traction. So I talked about first Sublime, the cement company. They're already, they have a first project live, which is in Boston, using their cements to make an office building. Then I talked about H2 Green Steel. They're not producing steel yet, but their plant is being built as we speak in Sweden. And the last company was, of course, Rondo Energy, where I mentioned they have a small unit live today with a cement customer, actually. And they're working on building larger units as well. So kind of similar, all these companies have their product in the market, probably not profitable yet, as Lisa mentioned. And in reference with the industrial cooling topic, we haven't seen a solution kind of like Rondo that couldn't address industrial cooling throughout different industries, but we've seen solutions that help address the kind of or improve the energy efficiency of the energy consumption of cooling. For example, industrial is a company you could think about there. We've seen district cooling solutions similar to district heating. For example, Gradient is a company you can look up in that sector. And lastly, we think we also have to be quite smart about reusing waste heat, as when you're cooling, you also produce heat, so you can reuse the waste heat from those facilities. And yeah, maybe lastly, I'll mention actually the cooling of data centers is a hot topic today, of course, data centers. So we've seen solutions that help reduce the energy consumption from cooling data centers specifically. Yeah, hope that helps.
Yeah, great, Carol. And you're getting another question, which is, have we seen any cool innovations in industrial food waste and circularity? Or maybe it's you're better equipped to answer.
I myself have not found or seen a lot of companies in this space, but maybe you, Lisa or Carol.
Yeah, there's two companies I'm thinking of. One is a company that helps in commercial kitchens to avoid food waste by actually measuring what is put in a bin. So there's actually a camera on the bin with an AI that actually registers what it is you're throwing away and then giving you advice on how to improve your purchasing or recipes. Could someone remind me the name of the company? Is it from the Arcturn portfolio?
Yeah, it's called Winnow Solutions.
Winnow Solutions, thank you. The other company I'm thinking about is from a previous fund from our partners. And what they do is when fruit and vegetables are no longer fit for purpose to be sold in supermarkets, they recollect them and use them to produce biofuels. So it's just two examples. All right, let's move on to transportation. I'll walk you through transport. 14% of global emissions. You might think that with all the attention for aviation, it would be more, but it is only 40%. And of that 40%, most of it actually comes because of road transportation. So that's 10% of global emissions. And within road, it's mostly passenger cars, just because we have so many in the world. But obviously also think about trucks and other vehicles. And then there's the famous aviation, and shipping is actually just as big of a problem as aviation. So also something not to be underestimated. Now, fortunately, the transition in roads is well underway. Electric vehicles, according to a recent study, just hit price parity in the US, and operating costs are lower and you get subsidies. So we're really, I would say, well past the tipping point of electric passenger cars. On top of that, we're figuring out how to make electric trucks, which 5 years ago wasn't really a thing, and now it is. So there we're well underway. But the big challenge in road transportation, let me take you to the first example, is how to actually get enough materials to make enough batteries to meet all of that demand. So we see a lot of activities in either making innovative battery chemistries or better battery components to improve their performance or measure their performance better, or actually extract and recycle the materials we need more efficiently. And SiTration is really a transformational technology in that regard. They make a membrane from silicons, which basically enables you to filter out all the different materials that you need for batteries one at a time at super high efficiency and very low energy use. It's hard to kind of overstress how excited we are. And the technology can actually be used in 2 different stages. So right now, most of its applications will go towards extracting even more from the mines that we already have live. So in the world, we have enough materials to make all the batteries that we need until 2050. But the challenge is that we need to open more mines, and opening a mine is very challenging, very expensive, very riddled with environmental and social risks. So the best thing and the fastest thing we can do is to extract more from the mines that we already have. And what you can do with SiTration is actually you can add it as a 3rd step to your process. So first you get kind of the rocks out of the mine. Then you use the traditional chemical process to extract the minerals and the metals from those rocks. And then you have this nasty waste sludge filled with chemicals. And then you can apply SiTration to extract even more battery materials from that sludge and make that sludge easier to dispose of afterwards. So we're really increasing our extraction rates and making sure that we can get more batteries live faster. As we have mined all the minerals we need, and for different expectations, different studies say that somewhere between 2030 and 2045, we will have mined all materials we need to indefinitely make our batteries circular. So mining is actually really kind of a problem for the next 20 years, but after that, we will probably end mining. But we will need to recycle all of the batteries that we have, and that's where SiTration will be very effective, because their selectivity, so the ability to effectively pick the right metals out of a mix, is 95%, and it's really significantly higher than any other solutions we see. So we think on the longer term, SiTration will really help with recycling batteries. So that was road transport, mostly electrification. How are we going to solve for aviation? The big problem with aviation is we need to go up into the air, and we don't have a lot of ability to carry weight, meaning that batteries are too heavy, and so we can't electrify aviation. And we can't carry a lot of space, making certain electricity derivatives, such as hydrogen, challenging to take with you, because hydrogen, unless you put a whole lot of pressure on it, it takes up a whole lot of space. So right now it still looks at least for long distance aviation, we will need some sort of fuel that resembles kerosene. Fortunately, we figured out how to make kerosene either from biomass or directly from CO2 and hydrogen. And Metafuels has an innovative technology that actually can do both. So it can use either biomass or hydrogen and CO2 to make synthetic kerosene. And they do it in a different way than most other companies do. They call it AeroBrew. And the great news is that it looks like this will be easier to scale than a Fischer-Tropsch, which is the current technology that some of their competitors use. And then the company to dive even deeper into is Calcarea. I think we pronounce it as Calcarea. This is really, sometimes we see something that we haven't seen before, and we're like, wow, we didn't know this was possible. Calcarea is an example of that. It's funded by probably the earliest stage fund manager we work with, Azela Ventures. They do the very first ticket into companies. And so Calcarea is still quite a young company, but they have been making good progress. And what they basically do is, so naturally the sea is pretty good at absorbing CO2 from the sky and sequestering it permanently. And they figured out how to do that on ships in an accelerated way. Because the bad news is that ships produce a whole lot of CO2 emissions from all the fossil fuels they burn. And a little bit similar to aviation, especially for the long distance shipping, it's hard to electrify because they need to go so far and batteries can only keep so much energy in reserve. And hydrogen is just hard to move around. So we probably will need synthetic fuels at some point, but they're not available yet. And once they become available, they likely will still be quite expensive. So an alternative is to see if we can capture and store the CO2 that we're producing on the ships as we're burning the fossil fuels. And Calcarea does that by actually just taking the exhaust gas from the ship, which has about 5% of CO2 concentration, putting that in a tank with seawater and limestone. And then those little bubbles bind to some components from the limestone and create a new chemical formation that is actually very stable and very abundant in the ocean already. And that can just be released into the ocean without disturbing the local ecosystem. It's called bicarbonate. It's very, so it's naturally occurs in the ocean really quite a lot. And it's actually also a molecule that shellfish and corals use to grow. So they might even support local ecosystems. What's so great about it is that the technology doesn't take up a lot of space. It's very efficient. You don't need a lot of electricity. So sometimes you need to use a lot of energy to capture CO2. In this case, it's very limited, and it also makes it quite low cost. And you can sequester the carbon that you capture en route, rather than needing a big tank to keep all of that CO2 combined until you hit a port and you still need to get rid of it. So potentially transformational, especially, yes, Albert, it's almost too neat to be true. I agree with you. Sorry, this is coming from the chat. So I will say almost too good to be true. Also still early stage, right? So it's a great idea. The technology works on a smaller scale. Let's see how quickly and how effectively we can put it to work on a larger scale. And maybe just to be also mention some of the downsides of a kind of technology like Calcarea. We will actually use fossil fuels, at least in the near term. And fossil fuels, as Eva mentioned, we create emissions from fossil fuels before we burn them, right? So those emissions will continue to exist. And also Calcarea reduces the carbon footprint of a ship by 75%, but not 100%. So it captures and stores the majority of the carbon dioxide that's produced, but not everything. We have one question from Gideon. What are the systemic challenges the energy sector faces in scaling up renewable alternatives to replace fossil fuels? That's a big question. How do you feel about taking that, Eva? We can also save it to the end.
No, I think I can answer that one. I think from our view, indeed, we see a lot of things happening on a systemic level, but the things I did mention before a bit already, but I think mostly like grid congestion. So the challenge here really is that we need to produce so much electricity with a rising demand, for example, because we need to electrify everything, but also because we use more data centers that need more electricity, but we cannot put all the electricity we produce on the grid yet. And especially we need to expand the grids then. But that takes a lot of permitting time, and often it can take up to years before we can build new infrastructure. So it's just going really slow. And then secondly, really solving that intermittency problem. So like I mentioned, solar and wind are electricity sources that are not always there because the sun is not always shining, the wind is not always blowing. So we either need to store it somewhere, so we can use it at a later time. That's really a challenge still, because with fossil fuels, you were actually able to use it always. You always had power. It was always, we could always generate electricity. And with renewables, it's a bit tougher. And that also brings me to, I think, my third concern is that we really need to increase baseload power. So that is power that we can actually have access to all the time. And a great example of that is geothermal energy. So we have a company in our portfolio which is called Vervo as well, and they're really like getting towards the energy that's actually stored below the ground in the forms of heat. So we can extract it from the ground and we can translate it into electricity, but also nuclear to make it more safe. A super cool startup doing that is Commonwealth Systems. And another form of baseload power is more related to biogas, so how we can use biomass to generate electricity and how to do that in an environmentally sustainable way. So I think that is my top 3 concerns.
Thanks, Eva. And maybe out of curiosity, I don't know if Gideon was also referring to that, but when it comes to sustainable fuels, so fuel alternatives, are those easy to scale, or are we also facing challenges there?
I think we're definitely facing challenges there as well. For example, with hydrogen, so that the Koloma, like drilling for new hydrogen, is a challenge, but also generating green hydrogen is still a challenge. And then you have biofuels, obviously, which we can use in ships, for example, or which we can use for long haul transport. But there is a limited feedstock supply for biomass globally available. So also, there are a lot of challenges.
Thanks, Eve. Renske actually put, I think, a very important comment in the chat, which is that ships use very, very dirty fuels, which means that it's not only CO2 that's being released, but a whole bunch of other particles that are damaging for the climate. And so, indeed, Calcarea is not a perfect solution. I think at Carbon Equity, we spend a lot of time around thinking about impact now versus impact later. So how do we view technologies that have the potential to improve the current system that we have by a bit or quite a bit, but not solve all challenges fully when it comes to climate? And there, indeed, we take a view similar to what Renske mentioned, which is, okay, but is the full solution still compatible with what it is we're already doing? And indeed, with Calcarea, today, we can use this technology in combination with fossil fuels, but in the future, we can use it in combination together with synthetic fuels. And that's actually very important because there maybe ships can even become carbon negative. All right. I muted myself, apologies. We're moving on. There's a few more questions coming in. I'm going to save those for the end, just to make sure that we do have time for every sector. So I'm handing over for buildings.
Yes, I will take that one. So buildings also a pretty interesting sector, I would say, because they contribute around 6% of global emissions. It already starts with construction of the building. So a lot of fossil fuels are being used there to power the construction. And when we live in buildings or work in buildings, we heat them, we cool them, and we use power for our lights and for our computers. So buildings actually a big emission problem. So many buildings are not energy efficient. They consume a lot for heating and for cooling, but 4% of that heated or cooled air escapes because the buildings are not well insulated, for example. There are a lot of challenges to decarbonize buildings. Then buildings come in different sizes, for example, or shapes and types. So standardization of things like insulation is quite hard. And also landlords need to pay for making buildings more sustainable, while actually the renters benefit from energy efficiency, for example. So it also requires a lot of time, upfront investments. It's quite expensive to buy solar panels, to buy heat pumps, and some cannot afford that. But we do think it's possible to decarbonize buildings with the technologies we have already here today, and with the business models especially we have today. And that also brings us to the first 2 companies. So the first one is 1,5, it's a European German company actually, that really tackles the problem that homeowners really want to switch to renewables, but that implementing clean technologies can be very difficult and also very expensive. And there's also a shortcoming of installers, which is also a problem. So 1,5 offers a platform for of installers that specialize in technologies like solar panels, heat pumps, but they also developed a software that you can manage energy use of buildings while also reducing the cost. They already operate in 7 countries and are really their leading player in Europe, I would say. So they're also doing good on revenues and are actually profitable, to answer a question of earlier. So that's a super exciting company. And then you have Luxwall on the right-hand side, and they really tackle the problem that buildings are like leaky containers. So especially if they have single pane windows, a lot of energy is lost via glass. And Luxwall developed glass windows that prevents this loss of heat and cooled air. And they do this by developing windows that are sort of like a thermos bottle. So you can replace your windows in existing buildings or use them for new buildings, and they reduce heating costs by 45% and cooling costs by up to 20%. They just built their first plant and will build a second one next year. That's also exciting. And then the third company is Blue Frontier. And Blue Frontier is really tackling another interesting problem, and that is the emissions coming from air conditioners, which are also a lot. So these emissions will only increase and increase, since climate change is also causing higher temperatures, so we will need more air conditioners as well. So they really this company really gets to the source of this emission problem for air conditioning, and they do this actually in 3 ways. So first of all, by creating air conditioners, which you can see here, especially for commercial buildings like hospitals or shopping malls, etc. But these air conditionings use 90% less energy. And that's actually possible because they use a salt solution that attracts the air and dry the air. And this dried air can then be cooled with a process called evaporation. And that's quite a natural process that occurs. And compared to the air conditionings we're using now, these need a lot of energy to move hot air to the outside and to cool the air. But Blue Frontier does not need that energy. And then secondly, they do not use harmful refrigerants. So normally you use chemicals, which are called refrigerants, that are used to cool air. But these can also leak out of the air conditioners, and they act as a greenhouse gas as well. And then thirdly, people in a country need air conditioners kind of at the same time, namely when temperatures are the worst. So that's often during the day. But we learned the intermittency problem. Solar and wind is not always there. So we need to store energy, and Blue Frontier's air conditioner can actually store that energy and use it whenever needed. So it's also acting as a battery. So a super cool company for the building sector.
Thanks, Eva. Yeah, very excited about Blue Frontier. We got a question on 1,5. I think it's an interesting one. What do you think is the main competitive advantage of this company?
Yeah, good question. I think they're a platform, and there are some indeed competitors in this field. I think 1,5 was really an early mover in this space, and what they do is they acquire installers. So they have just like a big network of different installers that have specializations in different fields. So for example, they acquire a heat pump installer, they acquire a solar panel installer. So I think their network is super broad. So they have a lot of technicians, which are lacking globally. So that network and their first mover, I think that's really their advantage here.
Totally agree. And on top of, they have one plan, let's see if it fully materializes, where they think that these installers are actually quite inefficient in how they operate. And by owning more of them and giving them better software, they think they can also improve their effectiveness and efficiency, and because of that, drive up margins. The second part of the question is also important. Why do we specifically choose to invest in this company? Good to mention here that Carbon Equity is a fund-of-fund investor. So it means that we select fund managers that then select companies. So we're not as directly involved in specific investments into companies being made. The reason we're doing this is that actually we really want to offer the best products on the trend of climate tech and work with the best experts in that. But we also want to create more diversification and only investing in one company in a space. And so even within these software platforms to help homeowners decarbonize their homes, we have multiple companies already in our portfolio. Also, for example, Soli and Voltaire, to just mention two other companies from Europe. All right, let's do the last one, carbon management, and then take the last questions that are still outstanding. Over to you, Itze.
Yes. So even with all efforts and the technologies we just discussed on reducing as much greenhouse gas emissions as possible, all major institutes expect that we will overshoot our carbon budget. That means that capturing carbon from the sky will be essential to achieve the goals of the Paris Agreement. And they actually expect that we need to capture up to 5 to 10 gigatons annually. So we can do this by using, for example, carbon dioxide removal, which is a wide set of technologies using both mechanical and organic options that all focus on capturing carbon dioxide and storing it for a long period of time. And I think these technologies should really not give people the wrong idea. So some might think, why would you stop emitting carbon when we can suck it out of the air? I think the answer really is that taking carbon dioxide out of the sky is really not very practical, nor is it economically very efficient. And there's really a finite amount of places where we can store it. So as such, carbon management is a tool to achieve net zero emissions, but only on top of all other reduction efforts. And we also need to emphasize that technologies can help in sucking out greenhouse gases out of the air, but in the end, nothing is better engineered to do this than nature itself, while also providing tons of co-benefits next to just carbon removal. So all of this is not to say that direct air capture or this space doesn't deserve any funding. I think it absolutely does, and we don't have the luxury anymore to rule out any technology, but I do think it's important to mention this. But let's move to the important innovations happening in this space. So first on to graphite. So graphite lets nature efficiently do the work of capturing the carbon dioxide, but often the fear with nature-based carbon removal technologies is permanency. So with the decay of that plant matter or wildfires, really causing the captured carbon by trees being released in the atmosphere again. So graphite gives nature sort of a helping hand by using an approach called carbon casting. So they use readily available biomass, such as residues from timber and farming operations, which would otherwise be burnt or left to decompose. And then they dry and compress it into dense carbon blocks. And these are then protected by an environmentally safe and impermeable barrier. And then they store these blocks in the underground site. And this means that nearly all of the captured carbon in the biomass is preserved for a long period of time while consuming very little energy in the process. Then to Air Company. So it's all great that we capture all this carbon dioxide, but what are we going to do with it? Does the molecule itself have more value than just reducing warming? And it actually does. So Air Company is one of the companies that turns the captured carbon dioxide into valuable materials such as jet fuel. So to do this, Air Company has developed a reactor that takes in carbon dioxide that is captured from the atmosphere and then uses a catalyst and electricity to split the carbon dioxide and water and recombine the elements into different types of chemicals. So the jet fuel that is produced through this process has actually up to 90% lower life cycle emissions than conventional jet fuel. And then on to the last innovation.
Sorry, yes? I just quickly, would you mind commenting on the video that the audience is seeing where rather than jet fuel, they see vodka and perfume?
Yeah, so they make a whole bunch of products. So it's not only jet fuel, but they can also make plastics and actually apparently also chemicals for example, for vodka and for perfume as well. So they actually sell these already on their website. I think it's great to have a look after this webinar. Then on to repair. So direct air capture, it's just using technologies to capture carbon dioxide directly from the atmosphere, is very energy intensive due to the concentration of these molecules in the atmosphere being really low. So if we actually would want to capture 1 year of global greenhouse gas emissions, would require the same amount of energy that the world uses every year. And of course, no one is proposing that we capture all of our emissions with direct air capture, but energy use is clearly a critical component. So Repair has actually developed an electrochemical process that uses 70% less energy than existing direct air capture methods. And it doesn't require heat, which is often needed now. So in short, what they do is that they, atmospheric air is drawn into an electrochemical battery at the cathode side, where it undergoes a reaction to form carbonate and bicarbonate ions. And these ions then cross a selective membrane within the battery to the other side, to the anode side, where the binding process is undone and pure carbon dioxide gas is drawn out. So conventional direct air capture companies like the famous one of Climeworks in Iceland, they use heat to strip the carbon dioxide from the solvent or liquid that captured it. But Repair uses electricity to achieve this. And this makes the process a lot more efficient. So when applied at scale, this technology could potentially decrease the cost per ton capture to less than $100 US per ton, which is sort of seen as the holy grail for direct air capture solutions.
Thank you. We have 3 minutes and we have 3 questions. So let's quickly run through those 3 and then wrap up. Carolina, for you, what exciting technologies are you seeing in the textile sector?
Yes, happy to address this. As I mentioned, textile is kind of one of those long tail of industries that is also highly emitting. And I'll highlight 2, actually maybe 3 that we have in our portfolio. So one thing you can do is recycle textiles at the end of their life. So currently when we recycle textiles, we use them to make other things like plastic or like plastic bottle alternatives. But we should rather, to make a fully circular supply chain, recycle it into clothes again. So we have 2 companies doing this in our portfolio. One is Side or Sire, Swedish company that is recycling polyester to make, again, polyester clothes. Polyester, as you may know, is made from fossil fuels. So addressing this or decreasing the new production of polyester is quite important. And we have another company doing a similar process, but with cotton. So basically textile to textile recycling of cotton. That company is called Circulose. And then another thing you can do is instead of reusing or recycling existing production, you can just change the production process from scratch. We have a company, super cool company, I would also recommend going onto their website, called Unspun. Unspun has created what they called a 3D circular weaving technology, lots of big words. Essentially what they're doing, usually when you make clothes, you have to cut up clothes and then kind of stitch the pieces together to make like a pair of jeans, for example. When you do that, you have a lot of waste. Basically all the parts that you didn't use, you have to dispose of in landfill or being burned, to be honest. And we usually do these production processes very far away in the world, for example, in Southeast Asia, and then you have to transport clothes to markets where they are sold. Unspun does 2 things. 1, local production, so you cut the transport emissions. 2nd, no waste. So basically their technology allows you to weave, for example, like a pant. You can weave a circle directly to make the pant, and there you don't have like the scrap waste. Yeah, maybe I'll stop there because we don't have a lot of time, but really cool.
Yeah, there's so much more to talk about. Very, very quickly on best battery energy systems. End of life, there is really 2 directions to go. One is extending their use, for example, for balancing the grid rather than running on cars. There's a few companies in that space. Think Stable and Relectrify. And then obviously we need to get really, really, really good at recycling. SiTration was an example there, but there's many more companies in the portfolio. Iron Fuel, very exciting technology, portfolio company from Rubio Ventures, a Dutch early stage climate and social investor. It is another way to decarbonize high temperature heats. There's a few advantages. It's easier to transport. There's a few disadvantages. It's less efficient. There's probably room for both because industrial heat is a really, 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 really big challenge to solve. And then finally, are we focused on specific CDR technologies? We are not. Again, we're a fund of funds, so we pick whoever we think are the smartest people in the world to invest in climate solutions, and then they pick specific CDR technologies. But as it's mentioned, generally, we tend to favor natural solutions because they're just so much cheaper and they have potentially possible co-benefits for ecosystems. At the same time, you need to be very mindful that you don't create any negative co-benefit or co-effects for ecosystems. And so within technological CDR, repair is really what we think is one of the most exciting directions, because rather than losing a whole lot of power to push a whole lot of air through, which is what, for example, Climeworks is doing, this process is just so much more energy efficient, meaning it will be cheaper. That's all, folks. The clock is ticking here, the bells are sounding here. I had a blast. Thank you all so much for joining, and feel free to reach out if there's still anything else you'd like to know. Have a great day.